Okay, this is the sheet that goes from 1 through 7. It's a front and back, and it says no calculator or calculator for each problem. So you need to get that sheet. You can press pause until you find it. So for number 1, and I'm using this extra thick marker, which I think is going to leave me with not enough room, but it feels so good to use it to write. Okay, so we get this. This is the original. Okay, so if you're like me, the first thing you're going to do is change it to 1 over radical 1 plus x and write dx, because I just don't like it on the top. Okay, so you need to find the antiderivative of this, and you're going to need use substitution. Okay, so we're going to make u equal 1 minus x. 1 plus x, and then du is just going to equal dx. Okay, so I'm going to rewrite my integral. I'm going to switch my dx and take du instead. And then I have 1 over radical 1 plus x, but 1 plus x is u, so I'm going to have that. Okay, so let me erase this. Okay, and now we can rewrite that as u to the negative 1/2 du. Okay, so this is going to be u. A negative 1/2 plus 2/2 is a positive 1/2 divided by 1/2, which is the same thing as multiplying by 2 as it goes from 0 to 8. Okay, but u is really 1 plus x. So we have 2, and then u to the 1/2 means a radical. And u is really 1 plus x as it goes from 0 to 8. So make sure that you substitute back before you're going to start plugging in these numbers, because you're going to totally get the wrong answer otherwise. Okay, I'm sorry it seems to be taking so long to erase. I don't know why. I have it on the biggest eraser, but I'm not cooperating. Okay, so now I'm going to plug 8 into there, and then we're going to subtract what happens when we put 0 in there. Okay, so 1 plus 8 is 9. The square root of 9 is 3. 3 times 2 is 6. 1 plus 0 is 1. The square root of 1 is 1. 1 times 2 is 2. And you will get 4, which is choice D. Okay, let's go to number 2. So number 2 was this. Okay, so you're going to pop this into your calculator, and you should get 1/2. So this is the Math 9 button that you're going to use. Okay, and that's it for that one. All right, let's go to the next one. So number 3. I think I better go to the thinner ink. It was this. Okay, now you might think, oh, I'll switch this to cotangent, but that's not going to get you anywhere. Okay, so this is u substitution. U will be sine x, and du will be cosine x. Okay, so I'm going to rewrite my integral. Okay, so I am going to take out the cosine x dx, and switch it for du. That leaves me with 1 over sine x, but sine x is just u. Okay, so this is just going to be ln of u. So it goes from pi over 4 to pi over 2. And then I'm going to substitute in for u, and we get ln of sine x as it goes, oops, it's supposed to be a 2, as it goes from pi over 4 to pi over 2. Okay, should be copying now while I'm erasing. So this is a non-calculator, so you're definitely going to need your unit circle for this. And we're going to be interested in pi over 2. So pi over 2 is located right here at the point 0, 1. and pi over 4 is 45 degrees. It's located right there. That's the only angle measure where the sine and cosine are exactly the same, 1 over radical 2. Okay, so now we're going to substitute. So we're going to get ln of sine of pi over 2 minus ln of sine pi over 4. Okay, I'm going to continue. Ln. Sine of pi over 2 is 1 minus ln of sine of pi over 4 is 1 over radical 2. Well, ln of 1 is just 0. So we get 0 minus ln of 1 over radical 2. Oh, I should have mentioned, oops, sorry, that this was the one that there was no correct answer, because none of them are even negative. So there was nothing to do there. The one thing that you could try and do, actually I didn't try this, let's see if this works, because I'm just thinking about that problem that Josh did on the test. The one thing you could do here is, this is really like a -1. Oh, this might actually end up working. Okay, so remember that power rule that if you have like a ln b, you can write it as ln b and bring the a up. So what if I take that -1? So I have ln of 1 over radical 2, and then I'm going to bring the -1 up. Okay, so then what would we get? We would get ln. Okay, so if you have something to the -1, think of this. If you have x to the -1, doesn't that turn into 1 over x? It means that it's going to move down to the denominator. So it's just kind of taking the reciprocal. So the reciprocal of 1 over radical 2 would just be radical 2. And that actually was a choice, so that's the answer, choice A. Okay, let's move on to number 4. Okay, so we're looking for the integral from -1 to 3 of f of x dx. Except we don't have a function for when it goes from -1 to 3. We have one function that goes from -2 to +2, and one function that is anywhere else. So -1 will be between that integral. So that first one is, it's the integral from -2 to 2. Okay, -1 definitely falls in there, but it's going to stop at 2. So we're going to have an integral from -1 to 2, and that function is 8 minus x squared. And then we're going to have to make another integral going from 2 to 3. And that one is the function x squared. Okay? So now we have to find the antiderivative. So we're going to get 8x minus x to the 3 over 3 as it goes from -1 to 2. That's the first piece. Plus x to the 3 over 3 as it goes from 2 to 3. Okay, you should be copying this unless you got it completely right, which would be great. Okay, so I'm going to work with the first one. Let's put 2 in there. So 8 times 2 is 16, minus 2 cubed is 8, 8 over 3. Okay, that's what happens when you put a 2 in there. Minus, okay, when we put -1 there, 8 times -1 is -8, minus a -1 cubed is a -1 over 3. Okay, so I'm just going to do one part at a time. So that's the first part. Okay, so we're going to get 16 minus 8 over 3. I'm going to distribute now. Plus 8. Okay, these two negatives over here, those become a positive. So when I distribute the negative times a positive, wait, what happened to my 8? A negative and a positive is going to be negative 1/3. Okay, 16 plus 8 is 24. A negative 8 over 3 minus a 1 over 3 is a negative 9 over 3. Okay, so that is going to give us 24 minus 3, and that gives us 21. So the answer would have to be C, because it's saying it's a number between 16 and 24. Okay, next is number 5, which is this. This is going to be U substitution. Okay, so you're going to say that U is x squared plus 2x, so du is 2x plus 2 dx. It's a little bit tricky. Okay, so obviously there's no 2x plus 2 in your original, but what if you write it, you factor out a 2? You do have an x plus 1. So if you divide both sides by 2, this is kind of clever, you get that, and we do have an x plus 1 and a dx. Okay, so we're going to go back to the original. I'm going to take out the x plus 1, and I'm going to take out the dx, and I'm going to replace it with 1/2 du. I'm going to put the 1/2 in front. And that just leaves me with e to the x squared plus 2x, but x squared plus 2x is u. Okay, and that's going to be 1/2. The antiderivative of e to the u is just e to the u as it goes from 0 to 1. Okay, let me get rid of all this junk. Okay, now I'm going to replace my u, so I get 1/2 e to the u, so u is really x squared plus 2x as it goes from 0 to 1. Okay, and I'm going to get rid of all this. Terrell, are you there? Were you in class on time today? Hope so. All right, first we're going to put in 1, so we get 1/2 e to the 1 plus 2 minus 1/2 e, it's just e to the 0. Okay, so it's going to give us 1/2 e to the 3 minus 1/2 e to the 0 is just 1. So we get 1/2 e to the 3 minus 1/2. But that's not any choices, but let's not freak out. So if we write this a little bit differently, I could write the first term as e to the 3 over 2 minus 1/2. And now I have a common denominator, so you keep the denominator and you just combine the exponents. And that is choice B. Okay, I'm moving on to number 6, which looks like this. Okay, there's no antiderivative for this that's going to make it easy. So we can rewrite this as sine of x squared over cosine of x squared. Okay, so here's where you're going to get stuck, because if you do u equals cosine, don't copy this, cosine x, then du is going to equal negative sine x dx. Divide by negative, you get this. And the problem is that you don't have a sine x dx to substitute in for. You have a sine x squared. So this is not actually going to work for you. And this is going to require a trig identity. Now, in all likelihood, you would not have a trig identity on the AP exam, but just in case, I'm going to show you how to do this. So there's a trig identity that says this: secant squared x equals 1 minus tan squared x. It's one of those identities like sine squared x plus cosine squared x equals 1. Okay, if you bring the tan squared x to the other side, you get this. And then if you bring the secant squared x to the other side, you'll get this. Okay, so what if we substitute for this tan squared x dx, what if instead we put 1 minus secant squared x, because they are equal to the same thing. Okay, the antiderivative of 1 would just be x minus the antiderivative of secant squared x, meaning what was it before? So when you took the derivative, you got secant squared x, it's tan x. Remember that? The derivative of tan x is secant squared x? And this is as it goes from 0 to pi over 4. Okay, so now we're going to substitute. First we're going to put in pi over 4. Minus, and now we're going to put the 0. Okay, and we're going to need our unit circle again. Okay, so here it is. So remember, pi over 4 was when sine and cosine were both 1 over radical 2. And 0 is right here. It's the 0.10. Okay, so we don't have tan on there, but we can change this to sine over cosine. Okay, so let's just change this a little bit. So we're going to have pi over 4 minus sine of pi over 4 over cosine of pi over 4, because sine over cosine is tan, minus a negative. I mean, we're going to change that to a positive. Maybe we'll just do that right now. Plus sine of 0 over cosine of 0. Okay, and now we're just going to use our unit circle. So we have pi, so I'm starting here. We have pi over 4 minus, okay, sine of pi over 4 is 1 over radical 2 over cosine of pi over 4 is also 1 over radical 2 plus, now I'm going to do this thing, sine of 0 is 0, cosine of 0 is 1. So let's simplify. So we have pi over 4 minus, well, 1 over radical 2 over 1 over radical 2. Whenever it's the same in the numerator and the denominator, so it's equal to 1. And 0 over 1 is just equal to 0. So if you look at all your choices, choice A is pi over 4 minus 1. And we have one more to go. So number 7 is this. This is going to be u substitution. So u is going to be 1 minus x squared. Du is going to be negative 2x dx, which is almost exactly the same. We just need to get rid of that negative. Okay, and now we're going to go in and substitute. So we're taking out this 2x and the dx, and we're turning it into a negative du. And we're left with 1 over radical 1 minus x squared, but 1 minus x squared is equal to u. So we're just going to change this around a little bit, because 1 over radical u is the same thing as u to the negative 1/2. Okay, so we're going to have a negative, and then we're going to have u. A negative 1/2 plus 2/2 is 1/2, divided by 1/2, which is the same as multiplying by 2. As it goes from 0 to 1/2. But remember, we have to substitute back in for the u. So we're going to have a negative 2. U is 1 minus x squared as it goes from 0 to 1/2. Okay, so we have negative 2, radical 1 minus 1/2 squared, minus a negative 2, so it becomes positive, 1 minus 0 squared, which is just 0. Okay, we just have to simplify. Okay, so we have that. None of these are choices. You don't see, well, you do see a radical, but no radical over a denominator. So remember, if we have this, that is equal to this, which would be equal to this. Okay? Okay, and then you can see these twos cancel, and you get negative radical 3 plus 2, which is choice E, and we are finally done.